In this book called Paradox by Al-Khalili, he talks about some of the more famous Greek paradoxes of Zeno. And this one of Achilles and the tortoise is very interesting. Achilles and the tortoise are going to have a race. Achilles is very swift, so he gives the tortoise a head start. The tortoise starts at point A, and they both set off, and Achilles at some point reaches point A, but by this time the tortoise has moved on to point B. And then Achilles eventually reaches point B, by which time the tortoise has moved on to point C, and so on. When Achilles reaches point C, the tortoise should have moved on to a new point, point D, ahead of Achilles, and it would appear that Achilles can never close this gap between himself and the tortoise. And so this conundrum mystified the ancient Greeks, and they wondered much and sorrowed more. And Al-Khalili points to what they were missing, which is something we teach in basic calculus courses. This statement that Achilles will never overtake the tortoise is wrong, of course, because in reality we can all see that this wouldn't happen, but it does seem rather plausible given the argument. And the problem with the argument is that Achilles does have to cover an infinite sequence of distances. The terms of the sequence are decreasing, but they're always non-zero. But of course, Achilles covers these sequences of distances in a sequence of time periods which are also decreasing. The thing that the Greeks did not notice or didn't come to terms with was that the sum of the terms of this ever-decreasing sequence of time intervals is actually finite. It's an infinite sum. It's a sum of an infinite number of time intervals, but it adds up to something finite. And that's what we're going to study in this section. Infinite sums, we call them series. Sometimes they add to something finite, and sometimes they don't converge. They add to something infinite, or they just don't settle at any particular number.